and common gate amplifiers. Now, here also we have a limited number of questions. Let us finish the problems and we'll take the lunch break. After that, we'll start the remaining module, final module. That's called practice session on common emitter and common source amplifiers. So first we'll see what the questions are related to this. In electrical workbook, I'm just taking this order only at this moment. So you can search out these questions in your easy book also. In electrical book, 5th chapter, we have 2 questions identified. In electrical book, chapter number 5. In electrical book, identified 2 questions. One is question number 19. Question number 19 is a common base question, and one more is a T1 question. This question actually is missing in EC book. Missing in EC book. So let us solve here in electrical book. Very interesting question this. Thevenin's equivalent model question. So EC students, please practice this question in electrical book, which is missing in the EC book. I removed that question, but very interesting question to learn. Only 2 questions are there. Coming to the chapter 7. Chapter 7 for electrical book, if you see, identified here also 2 questions. One is T2 and T4. T2 and T4. These 2 questions are related to common gate amplifiers. So these 4 questions today we'll finish up with some short notes practice, then we'll complete this task. Okay? Hardly 4 questions, so that we'll get an idea how to do the problems in common base and common gate amplifiers. So around 115 by 115 we'll reach the topics now. First 10 minutes I'll give the overview, whatever we studied we'll know 3 amplifiers. A table form I'll try to create, which will help the student to quickly revise the formulas. Let us see the table form now. Short notes is nothing but table form now. So let us have a short notes with the table form technique. So keep the heading short notes. Short notes. So we are going for each amplifier technique now. First BJT version. We see first BJT version. So keep the heading type of amplifier one side. Type of amplifier. One side you write. Take a column here and write down the input impedance. First point. The input impedance. And write down the output impedance. The output impedance. The voltage gain. And the current gain. So there are 4 formulas I'll create for input, output, gain and current gain. So these are the 4 issues we'll try to develop as a table form, which makes the student to understand the formulas. Whatever we study, he'll know. He'll recollect very easily know the points. The first amplifier name is common emitter bypass. This is the first amplifier. Second is common emitter unbypass. Next one we have is common collector amplifier. Last one we have is common base amplifier. So this is the total story of your amplifiers. Whatever we studied for 3 days, the total story will be in the single diagram. So one is a common emitter bypass, one is a common emitter unbypass, one is a common collector and one is a common. Yeah. Summarish वही कर रहा हूँ मैं. Total conclusion I am giving. See here. Input impedance of my common emitter bypass I have seen is R pi. You can see we got only R pi here. But whenever you said unbypass, the answer increased to R pi plus 1 plus beta times of Re. It has increased. Can you see the difference between the input impedances? When you say only the transistor impedance is without Re, it is only R pi. But when you say unbypass Re is there, it increases to the factor R pi plus 1 plus beta times of Re. Common collector also we have the same input impedance R pi plus 1 plus beta times of Re. So this is the behavior of your amplifier input impedances. Okay, these two have the same impact. But common base is telling I'm a low impedance. Okay, very low impedance. It is nothing but your Re parallel to 1 by Gm. Common base input will come from emitter. So emitter resistance Re parallel to inside impedance is 1 by Gm. So this is the story how the impedances will be different for all the 4 amplifiers. Take it as a first step. How to recollect the 4 formulas is this one. Next one, output impedance. If you see this answer, you can take it as RC. If you don't consider R naughts, only RC will be there. If it is a common emitter unbypass, so if you take R naughts also into consideration, it will be RC parallel to R naught will be the answer. If you consider here RC, will get parallel to, will get a very big formula here because it's unbypass I said. It is R naught plus, I said a trick for it. Re parallel to R pi will be there in series plus Gm into R naught into Re parallel to R pi. So this will come parallel to RC. So which is a very high input, high impedance will come at output when you take common emitter unbypass systems. So this is the difference between your concepts. If you take R naught into account, common collector output impedance is similar to common base input impedance. So you can see the tricks here. These two are same. These two are same. But here, these two are same. These two are same. This is my arrow indication techniques. So the output impedance of my common collector will be the same as input impedance of common base. And coming to the last answer, output impedance is RC parallel to R naught. It is exactly similar to this one. It is exactly similar to this one. These two will be same. This is the way how the links are coming. Okay? There are some similarities between the formulas. A common emitter output impedance will be same as common base input output impedance. A common collector output impedance will be same as the input impedance of the common base. These are my observations. The gain formulas are very easy. It is minus Gm into RC you can take. This answer is minus Gm into RC by 1 plus Gm into Re. So whenever you have unbypass, you will have a factor in the denominator 1 plus Gm into Re. If it's a bypass, we don't have. If it's unbypass, we have. A common collector is unbypass, so the formula will change to Gm into, in place of RC, you write it as Re load. RC place में Re लिखो, and denominator is unbypass, so the formula will continue with 1 plus Gm into Re. This 1 plus Gm into Re will come, which system is unbypass, that will repeat for that amplifier. And it is a positive sign here. This gain is a positive gain. And coming to the last formula, it is a plus Gm into RC. If If you see the similarities in the class, similarities, these two will have similarities, gain structures. In magnitude, these gains are equal, they look same. And there is a similarity of these two resistors if you replace. These also have the similarities. These two also have the similarities. So like this you can remember these formulas. Automatically, gains will come very easily. The last one we have is current gain calculations. The current gain formula here is beta into RB by RB plus R pi will be the answer. Here beta into RB by RB plus R pi plus 1 plus beta into R. So here similar answer. Here similar answer. And last answer is Gm into Re by 1 plus Gm into R. So this formula will be similar to this point. These two will be same. So these are the tricks actually. So one time who can close the book and who can visualize these formulas like this, you are confident in doing the problems. So this all formulas should be in your practice. Okay, this is the first BJT analysis. One time if you know BJT, MOSFET automatically will come. That's not a big issue. So BJT must have practice, MOSFET automatically write the formulas. Okay. So with the help of this, we'll solve the two questions given in the workbook. We'll try to solve it. Let us find out the solutions of the 4 questions. So when you are practicing amplifiers, just have this type of knowledge, then you can do whatever you want. Visualize the formulas from the diagrams should be in your imagination. Then only you can draw this total formulas. Whenever I say common emitter, that should come into imagination for you. Okay, common emitter bypass, Re will not be there. So it is R pi is the input impedance. Like that you have to visualize the formulas. So एक white paper लेकर first practice करो formulas को circuits को, then shortcut methods automatically will be remembered. But practice is required, nothing more than that. You can see these arrow indications. This will tell the similarities of the formulas. Here, this is similarity for us always. The output impedance of common collector will be same as input impedance of common base. The input impedance of common emitter unbypassed will be same as common collector input impedance. The buffer properties here, these are buffer properties. Voltage gain will be 1 in common collector, common base your current gain will be unity. Gains wise if you say they look bypass, they look unbypassed formulas. Like this you can recollect it. Yeah, Satyam, here both have same formulas. Current gain wise, both will have the same formulas. That only I derived in the notes. Okay. So let us start doing that. 2 questions will complete. That's the main job first for me. Let's see the first question. It's talking about some current gain calculations in the problem. So let us start the first question. First question, try to start. I'm giving a chance for you to do it. 19th question, try to solve it. EC electrical, question number 19 in chapter number 5. Akshat Kumar, here maybe I have given some, what I can say, signs I have removed in the class EI formulas, but here I think you may get here negative signs, here you may get positive sign. Okay? One will give negative, one will give positive sign. So current gain के लिए it is not important for me, but voltage gain compulsory. You have to tell the phase shift technique. If you don't have here negative sign, the negative will not come here. Current gain if it is negative, you will get this as negative. Otherwise, keep that negative sign like that, and current gain you show in magnitude. Okay? Then you will not have any problem because already the sign दिखाया आपको. So let us have this in magnitude. You can tell this answer without telling sign. Current gain you can explain in magnitude because if you write negative here again, it will become positive here. So keep it like that, negative. And current gain just to show me the practice of sign without sign technique you explain it. Current gain. Exams may they'll ask only the magnitude problems, so no worries. They not talk about signs. This formula, I said the trick for you here. Notes में एक बार write, go back and see the notes, okay? ये trick notes में दिखाया और एक बार I'll not teach you. Notes में back क्या कर और trick कैसे बताया एक बार देखो. Here I taught you one trick for this. Again you are making me to repeat all the things. Here one small trick I told you. This is Re, this is R pi, this is ground, this is R naught, this is Gm. This is the trick. R naught plus Re parallel to R pi, R naught plus Re parallel to R pi plus Gm multiply with these two components, Gm into R naught into Re parallel to R pi. और diagram देखकर practice करो बोलो. So let us start our journey. Chapter 5 we are doing. Chapter 5. In this we have 2 questions. Chapter 5 we have 2 questions identified. One is question number 19 and T1 question. First let us do the T1 question, which is a very interesting question to do. T1 I'll do it first. He has given a diagram like this. This is Vi. Next we have is 270 ohms. Next transistor is there. Next he connected a load. This is RL. He said that he want to write this as V Thevenin's voltage, this network. From here to here, he want to find out V Thevenin's voltage. That means V Thevenin, he want to find from here to here. So how much the Thevenin's voltage you have to find for common base system. So Thevenin's voltage, how to find out. So if you want to find Thevenin's first, you must know the model, AC model, how to represent for common base. So let us write the common base model in the structure, how to write is. T model I am writing, Vi. Okay. Next we have is 270 ohms. This is 270 ohms. Next we have is emitter point. This is emitter. I am not writing anything at emitter. Bottom side, we will write R pi. This is base to ground. This is R pi. Next we have is current source. This is going inward because NPN transistor. Gm into V pi. This is your collector. This is called T model I am writing. We don't want to keep load here. Thevenin's means RL should be removed. So only V Thevenin we are finding where RL we made it as open. So this is the way how we are finding the Thevenin's voltage. So you can expect if you open here, your load is open here. Okay? So it's not only that, he has given some R naught also in the problem. He said some R naught, which comes parallel to the current source, which is given as 250 kilo ohms. This is 250 kilo ohms. This is the way you are seeing the diagram. So when you open this load to find out the Thevenin's voltage, can I say that this current, whatever it's seeing, will be zero? Because it's an open circuit you have done to find out the Thevenin's voltage. If there is no current passing here in this loop, this current will be zero. But there is a current inside the transistor called Gm into V pi. This current plus this current will come here again. It also becomes zero. At this point, it will become zero. So from here to here, when it passes it is zero. Here zero, but here current is there. This current whenever is coming here, it is not going this side, so it will go in this manner. It will be rotating in the loop. So Gm into V pi, current will be going in this manner. So we'll take this current name as Ix. Same current is going. And here we have one current plus minus. You have a current flowing in this direction, no? Because the base current should go in this direction. We'll take this current name as I. We'll take this polarity as V pi. Okay? The current has to go in this direction. So let us have KVL VThevenin in terms of VI. You have to find this answer. How to find VThevenin in terms of VI? After writing the model, can we have here one KVL will apply? KVL, if you apply like this. KVL. So KVL at loop 2 I am applying. KVL at loop 2, it is minus VThevenin. Minus VThevenin. This will become a plus minus Vx will be there here. Some voltage drop is there here by this current source. So it is minus Vx. Current is going in this direction. So minus V pi should be equal to 0. So this is my outer loop equation. First nicely, one KVL I have written here. Minus, when you touch minus, it is minus. This is also minus. This is also minus. Total is 3. I made it as 0. So VThevenin can write it as minus of Vx plus V pi. So I want to write VThevenin in terms of V pi now. So what is Vx here is Gm into V pi is the current into R naught. It is multiplying. So you can write it as minus of Gm into V pi into R naught plus V pi. So VThevenin will be equal to minus of V pi common. It is 1 plus Gm times of R naught. So nicely I created a concept between VThevenin and V pi in the class. So from here to here I got the link. Examiner is asking the link from here to here. So first loop has given this information. So VThevenin is nothing but minus V pi times of 1 plus Gm into R naught. Up to here, there simple KVL से काम हो गया. Next KVL will see. If you want to find out this current in this loop, this current, this VI is opposite to this current. So we can find out the current as I is equal to minus VI divided by 270 plus R pi. This is your current in the first loop. It is minus will come because oppositely going. So minus VI divided by 270 plus R pi is coming. Okay. Now the point is, what is V pi here is I into R pi. It's called V pi. So VThevenin we can write as minus I into R pi into 1 plus Gm into R naught. So just I have written V pi as I into R pi. So what is I here is minus of minus, it will become plus. It will become Vi by 270 plus R pi into 1 plus Gm into R naught. So I think VThevenin we can solve it. We got the complete information given in the problem. So with this step, I think the problem will be solved. So let us finish that calculation. We have the complete data given in the problem. How much he has given is VThevenin is equal to plus Vi divided by 270 plus what is R pi given in the problem? R pi he has not given. So what we'll do is we'll make this as beta Re. In place of R pi, we'll write it as beta Re. Gm he has given, so beta into Re you can calculate. Beta Re into here beta Re you can write R pi is beta Re into 1 plus Gm into R naught. So just calculate these answers. Beta given in the problem is 100 and Re we can write as Gm. All these things you can substitute it. Plus Vi by 270 plus beta into 1 by Gm you can write. Here beta into 1 by Gm you can write into 1 plus Gm into R naught. So substitute all the data, we'll get the VThevenin voltage. So please try to solve this problem. How much answer you are expecting for this calculation? Beta given in the problem is 100. Gm is 2 millisiemens. R naught is given 250 kilo ohms. Everything is there in the data. So just one time calculate and see the answer how much is coming for this. VThevenin voltage. I'll substitute otherwise here. Vi is equal to Vi divided by 270 plus 100 into 1 by 2 millisiemens. Here 100 into 1 by 2 millisiemens into 1 plus 2 millisiemens into 250k. How much is this value? Just solve it. Give me the message for this. Which option is matching? Try to solve it and see that we'll keep the correct answer for this. Rahman, this is a NPN transistor here. This is an NPN transistor. Emitter current has to go like this. Collector current has to go like this. Base current has to go like this. Actually, your current directions are like this. That's why the current movement came in this direction. But perhaps here what happened is IC current became 0 in the loop. But that's why IB, IE are looking same in the loop in the transistor. Okay? 498 VI. We're getting around 498 VI will be the answer for it. Okay? So this is the way how we can solve this type of Thevenin's problems. They're looking very interesting. That's why EC students, please try to understand this question. Gate level, they may ask you this type of questions. Okay? Just equivalent models you have to write properly and finding the first KVL's relations you can find. You'll get the answers very nicely. So one more question is there, the same impact. Current gain calculations, we have one more question. Question number 19, we'll try to see. Question number 19. Question number 19. Let us start doing question number 19. Second question. Question number 19. Question number 19. Let us see the next problem. Question number 19, if you see the problem. Just given a common base problem. Vs. We have a capacitor with a 10 kilo ohms. With a 10 kilo ohms. With a battery 10 volts. The PNP transistor. PNP transistor. Having here 5 kilo ohms with minus plus 10 volts. This is your output. If you see correctly this problem, it's a PNP problem. PNP means the current will go like this. This is IE, this is IC, this is IB. First you notify the currents. It's asking you the current from here. This is II, this is I0. So it's asking can you calculate current again. So don't do any derivations. It's a buffer we know. So the formula is Gm into Re divided by 1 plus Gm into Re. I think it's a straightforward, the current buffer concept. Current buffer. Don't write all the models and waste your time in exams. Okay? Recollect the formulas, with that solve the questions. It's a current buffer, so formula I represented Gm into Re by 1 plus Gm into Re. This can also be simplified as Re by, you can practice like this, 1 by Gm plus Re. Easiest way of writing this formula is Re by Re plus small re. This is another way of practicing the same buffer form. So it is Re by Re plus Re. Already in the problem, Re is given in the question. This is Re. So our information is Re is known to me. Only small Re I don't know. So to find out small Re, compulsory passing circuit is required. So let us go for DC circuit. Only DC circuit if you see, it looks like this. This is 10K, this is 10 volts, this is a PNP transistor, this is ground, this is 5K, this is your 10 volts. So maybe this is the DC circuit. Coupling capacitors, all these things are left over. To find out Re, to find out this answer, we need the DC circuit. Biasing circuit is required. So in this, can you see, we have a diode, which is having here 0.7 voltage. So we can have a loop here, IEQ. Straightforward, you can solve IEQ current here, in the single loop. So IEQ is nothing but, it is a 10 minus 0.7 by 10K. 10 minus 0.7 will be 9.3, so it is 0.93 milliamperes. So this is the way how to solve the operating currents in common base amplifiers. In a single step, we'll get the operating current. If I know operating current, which is equals to ICQ, same. So what is RE formula is, it is VT by IEQ or ICQ, both are same. VT by, in this problem I think he has not mentioned any VT, so we can write it as 25 millivolts by 0.93 milliamps. So this must be your RE. Just solve that answer and see that how much this EI value coming in the problem. 25 millivolts by, just I'll calculate it. 25 divided by 0.93. This is coming to be 26.88 ohms. This is coming to be RE value. Okay? Whenever you want REs or GMs, go for biasing circuits always. So what is the answer here is EI. It is RE is 10K, 10K by 10K plus 26.88. 26.88 divided by 1000 you take. It will become 0.026 kilo ohms. Converting the value in kilo ohms. This value will be, or we can write 0.026 kilo ohms. Kilo ohms may convert it. So this answer you can see 10 plus 0.026. 026. It will be 10 point. So 10K by 10.026K. 10.026. It's coming to be 0.997. So if you see, the answer is coming close to the 0.099 is close to the 1 it is coming. Okay? This is the way how you can solve it. So Raghavendra, I think it's coming 0.997 something is coming. आपको 0.987 आया थोड़ा calculation देखो. Have you done mistake any calculation? 0.997 I'm getting. Yes, boss, 0.997 is coming. Correct. So that means in the examiner, if they ask you, fill in the blank, you should not say the value 1. You have to tell the decimal value like this, 0.99, sometimes 0.98 will come, 0.97. You have to tell this type of answer from the accurate calculations. Generally, 10K plus 0.026K is negligible, but examiner will ask you 2 decimal answer, they'll use the board. At the time, you have to tell the decimal value. So 0.99 will be the 2 decimal value. Okay? Like this, you can tell the answer. So this completes my concept on 2 problems based on common base. Now come to the final analysis. If I go for MOSFET questions, what are the questions are there? Let's see. MOSFET questions will be the final. MOSFET questions, try to see. Chapter number 7. MOSFET questions. We have 2 questions I think here. One is T2 question. One is T2 and one is T4. T2 question is very interesting. See the T2 question. RT is given as 2 kilo ohms. This is VDD. Has got a MOSFET. This is ground. There's a current source of 10 milliamps. There's battery minus VE. There's a capacitor here. We have resistance. R signal is 50 ohms. There's V signal. And we have capacitor with a load. This is 2 kilo ohms. This is your output. So if you see, this is a common base amplifier, common gate amplifier I'm thinking. Why it is called common gate is, my input we have given here. The input is given at source. This is the input. Output we have taken at the drain. It's asking you, please find out the output voltage for this. Then what is the value of output voltage? Output voltage becomes what? AVS times of V signal will be the answer. It is not AV, you have to calculate AVS. Okay? Because here, please remember, here RS is given. RS is given. When RS is given, be careful with the answer. What I said is, AVS will become AV times, whenever RS is given here, it will become RI in divided by RIN plus R signal. So this extra factor we should not forget whenever the question is given like this. AB is transistor gain, common base gain. AB formula, we know. RIN means the input impedance of your common base transistor. And RS, this is the equivalent we are finding there. Okay? This is the equivalent. That means I have written like this. This is your B signal. This is R signal. Here we have some input impedance called RIN. This is your EI. So up to here I know the gain, but up to here you have to find. Okay? At that time we have some voltage division rule called attenuation will be there. So first find out the normal gain, common base gain formula is plus GM times of your RT parallel to RL. Up to here I know the formula. It's just a common emitter gain. In magnitude I have written the answer. It's a common emitter gain. GM into RT parallel to RL because we have two loads here. So first finish this answer. In the problem I think GM is given or not. So GM is not given. Then how will you solve this problem first? If I want GM, first practice the GM formula. GM can be represented as under root of 2 ID into nu n Cox W by L. This formula I derived in common collector formula, correct? This is GM formulas in terms of ID, which I created in common collector structure. So that formula wise, first you solve the GM, how much? 2 into, your ID is here, 10 milliamperes, into nu n Cox W by L. Half you keep it half here, into, half is not there here, correct? Half is not there. Nu n Cox W by L into 2 is also there. So you can write here, in place of writing like this, you can write it as, this total value has been 10 into 10 power minus 3, it will become 2 into 10 into 10 power minus 3, right? So this answer you calculate first. GM how much will come? Calculate from this. I think this milli cancels. This will become 4, this will become 4, this will become 100. Root out 400. 100 is 10, okay, 4 is 2. So we'll get here 20. So GM is coming around 20. GM is coming around 20 milliampere per volt. 20 milliampere per volt. So this is called GM, how I found with this formula. So what is the gain formula is? It is 20 milliampere per volt into RT is 2K parallel to 2K. 2K parallel to 2K. So it will become 1K. 1K into 20. The answer is 20. So AB formula we are getting 20. AB is coming to be 20. Yeah, sorry for that. This is also milli, this is also milli. They will not cancel here. Sorry. So what we will do is, by mistake I think I have cancelled it. This is milliamperes. So that is the reason we got finally milli. This is milli into milli, so that you can take here milliampere per volt. So 10 power minus 6 will come. If you take the root, it will become 10 power minus 3. It is not cancelled. Sorry, by mistake I have done it. That's why milli will come here. 10 power minus 3. Keep it like that only. So you get milli, 20 milliampere per volt because of that. But this is not a correct gain for you. You want ABS answer. The answer chahiye aapko. ABS if you want. What is RIN here is the input impedance from the source will be 1 by GM for us. For a common base, the input impedance will be 1 by GM. So 1 by GM will be how much is? This will become 1 by 20 milliampere per volt. This is your value. So RIN how much it is? Please find out. RIN. I think it will become 50 ohms. R signal is also 50 ohms. Both is coming 50-50. So the ABS answer is 20 into 50 by 100. 50 by 100. So it is coming to be 10. So ABS, we are getting here 10 is coming. When ABS is 10, the output will be 10 into V signal given the problem is V signal how much he has given? 1 millivolt he has given. It is given as 1 millivolt. So output will become 10 millivolts. So this is the way how you can solve this question. So very interesting questions. These questions you practice it. So 10 millivolts. First of all, we will have subject knowledge. Option A, option B, they'll say wrong because minus never come because they are not phase shift amplifiers. Only option C, option D will be the correct that I found in the class. Some students will write this answer actual 20 millivolts because you try to forget that R signal is given. We have to take some attenuation factor. You try to leave that one. Then mistake will happen in the problem. So whenever RS is given, the transistor gain formula and the circuit gain formula will not be same. If you want an extra, you have to take this ratio always. Okay? It's a very good problem. Good practice. Last question is T4 is the final question. Let us complete T4. Try to see that last question. With that, we'll stop this. We'll take the break. After the break, we'll complete the remaining portion of problems in common emitter and common source amplifiers. Today class, perfectly we are completing the schedule. Okay? According to my plan, exactly it is going on time. Perfect. So the last problem here, T4. Everybody can tell this answer by them easily. You can tell it. T4 answer. T4 answer. Straightforward. You can tell the answer. Circuit is looking big, but answer is very easy. T4. What will be the answer? They have got a common base amplifier, common gate amplifier. He is asking from the gate. What will be the? Sorry, from the source. He is asking what is the input impedance. That is a simple question. What is the input impedance from the source? So what will be the option for it? Yes, very good. Both, great, good answer. Last question is very simple. T4, if you see, he has given here PA input. We have RSI signal. There is a coupling capacitor CC1. Next we have is MOSFET with some RG. You can keep a capacitor here, CG. And we have RD with a V minus. There is a capacitor CC2. And we have the load. This is your output. A very simple question it is. He has given a current here, some ID. Exactly at this point, source is asking you what will be the input impedance. From the source, from the active load knowledge, the answer if you see from the source, it will be 1 by GM. Correct? From the source, if you see, the answer will be 1 by gm parallel to some r pi, all these things. But in the options, if you see, it is given only 1 by gm. If they give 1 by gm parallel to r pi, you take that. If they don't give only 1 by gm, you take that is the correct answer. So input impedance from source will be always equals to 1 by gm, which is called low input impedance. So this completes the answer. Option B will be the correct answer for this. So nicely we have been completed the total practice. So perfect. Now you can take happily the break. It is now 1:10. I think you'll get 50 minutes break now. Okay. Up to 2 o'clock you can take a break. 2 to 4:30 we'll work on remaining problems on common emitter and common source. We kept that video as a part 1. Now today we are covering as part 2 of common emitter problems. Anyway, good. Timing is going well. So around 2 p.m. sharply we'll start the class. Okay. Break is up to 2 p.m. So 2 to 4:30 is my class. By 4:30 we'll finish the job of that remaining problems for you. This is Shubrat Rata. Thank you very much. Thank you very much, Shubrat. Thank you very much for your compliment. So only one thing I believe in my life is discipline is very important. Okay, one thing that is the most successful for my life. Any class is there, half an hour before only I'll be here. Really speaking, I'm traveling after this class to my home. Nearly takes around 1 hour to on metro. I'm going from here to there because traffic jams, all these things will be there. To go from here to in Hyderabad, I'm telling, it is far away. My office is far away to my home. Nearly takes 1 hour. After metro, my driver will be waiting for me to go to home for that half an hour. Nearly 1.5 hour traveling is going daily. Morning, I think if I want to start here 8:30, there morning I have to wake up at 5:30 morning. 5:30 to 6:30, I'll be fresh up all these things. 6:30 I'll try to start to go to the metro station. Around 7 o'clock I'll start my journey. 7 to 7:45 exactly I'll reach to the office because metro is very close to the office. Exactly at 8 o'clock I'll be here. Daily I'm taking classes like that actually. Okay, but traveling around 7 o'clock to 8 o'clock I'm coming shortly by 8. By 7:45 I'll reach. 10 minutes I'll refresh. By 8 o'clock I'll be ready for the class because I don't want to come late to the classes. That is very important for my life. Okay, discipline is one of the best points which will give a good success to the persons. Unnecessarily wasting the time, coming late, okay, teaching the points in a different manner without giving a correct information. These all things are bad things. Anything you do, straightforward you explain, okay, with well discipline. These all things you can learn from us. Whatever we do, you just practice it. In future you'll be success in your life. Okay, God bless you. Definitely, if you do like this, you'll be good enough for this. Thank you very much for your nice comments. So I'm feeling happy that completing successfully each and everything well. That's a great thing. That's a great thing. So complete this and take a break. You can leave. Around 2 o'clock we'll start the remaining problems. Okay? Around 2 o'clock we'll start the remaining problems. So let me take break for 5 minutes at least. 2 o'clock we'll start the practice of remaining questions. Thank you. Take a break. 2 o'clock we'll start.